Hey everyone, welcome to day 2 of NDSML, the ML and Engineering Day. We are having an exciting panel on how to leverage DataOps and MLOps to operationalize machine learning and AI. With me I have 3 great guests, and I'm going to go ahead and let them introduce themselves so that we can get started on this interesting discussion. Please begin. Let's see here. Anyone that would like.
I can go first if you want.
Yes, please.
My name is Hans Harf Andersen, and I work for Vestas Wind Systems, so a big wind turbine manufacturer who also services 100 gigawatt of wind turbines across the world. And I work as a data specialist and data scientist in our modeling analytics team, where we sort of apply machine learning and data science to both the design and the siting of the turbines, and also sort of looking at how are they performing in the field and how can we optimize using the latest and also the oldest technologies available.
And Nishant?
Hi, I'm Nishant Raj. I'm the Data and AI Strategy Lead for Atlas Copco IAS division. So my focus has been corely within the automotive division, where we supply tools that help join car bodies together. So it's within the core engineering domain, and my role is sort of a big step change in terms of looking at industry, where trying to utilize data and where in automotive plants, it's something that we're still getting started on that journey. And I've previously driven Industry 4 digitization across our businesses. So yeah, it's an exciting time for us. I'm looking forward to this discussion to further share some of the insights and learn from others as well.
Excellent. And Hagai.
Hey there. So my name is Hagai Lupesco. I work for Facebook, and I lead the development of Facebook's internal AI platform for personalization, which is essentially ranking and recommendations. The platform is used by over 1,500 developers across all of Facebook, and it powers the models that serve recommendations to over 3 billion people worldwide. So excited to be here talking about MLOps.
Awesome. Yeah, well, all right. Let's see if we can add some nuance to this discussion and introduce what MLOps actually is. Because yesterday we were discussing how machine learning has a lot of, is trying to absorb a lot of learnings from software development that we've had throughout the years, and is very much maturing as more companies are trying to deploy it. Now, the question is, I personally believe that a lot of the AI revolution is due to deep learning and some of the more sophisticated models, but that's not the only thing people are deploying now. They're deploying more traditional models. Is this something that is late coming, or is it very specific, like a requirement of those advanced models? You know, we've had analytics and databases and that kind of thing for a long time. Is this something that we should have been doing a long time ago? Or is it something that really is required by the new techniques that have been emerging?
So to jump in here, from a manufacturing standpoint, manufacturing industry has had data collection available with in-house databases and servers for a long time. But now is when there's a bit of opportunity starting to come where actually suppliers can get access to that data remotely. Customers within automotive getting a bit comfortable in terms of sharing the data through a cloud strategy, which previously wasn't even possible. All of these things are enabling what can be done with the data. And it's also, from my experience, where deep learning and the traditional models are all good, I think the key thing boils down to is what problem are we solving, and identifying that and then applying the right solution towards that is key. So if it can be solved by a simple automation, then you do not need a machine learning model to solve it. But similarly, if it can deliver better results through a machine learning or deep learning model, then that's what's required. So for within manufacturing, with my experience, I think it's new, but it is looking at how do we solve a core problem, and then what's the best way to solve it.
Hans, what do you say? I mean, part of it is that there's different kinds of requirements in MLOps. Now we have self-supervised models. We have all sorts of different kinds of machine learning models that might need. Is this something new or something old? Oops, you're muted. A guy, you want to give it a try? Oh, no, there we go.
Yeah.
Now it sounds like no. Go ahead, Hagai.
I'll jump in, and Miles, maybe you can chime in later once we reconnect. So I remember the days earlier in the days before the deep learning revolution, or before deep learning really kicked in. Personally, I was doing a lot of computer vision work. And the issue about, setting the high engineering standards, high engineering bar on the algorithmic part of the work, that gap always existed. However, it was less of a challenge because what deep learning really brought in is a huge scale that is just actually increasing every day. You look at the best NLP models of 3 years ago, they're 100x smaller than the biggest NLP models we have today. But if you look at the data it's trained on, it's actually a few orders of magnitude larger. So deep learning really brought in immense scale for the data, for the models, for the pipelines that need to power all of that. And I think that just really made the gap on the engineering side between the science and the productionization much more clear. And MLOps has been really desperately needed. So you see it kicking in. And one key example is reliability, right? If your model is trained on a few thousands of examples, right? It's actually not difficult to get high reliability, for example, in a data pipeline. When your model needs to be trained on billions of examples, or in our case, it's even trillions, then getting high reliability is a whole different ballgame. It's like it's the same as running Amazon.com, right? At that scale, right? Or Facebook.com or whatnot. This really enforces a hard requirement for things like reliability, disaster recovery.
What kind of reliability are you talking about? Of the model itself, or of the entire system, from deployment to monitoring of performance and that kind of thing? What aspect of reliability is the challenge?
Yeah, I think in general you want end-to-end reliability, right? So you want high reliability on your offline training pipeline. You want high reliability on your model serving system. If you ask me, from my experience at least, where is the big challenge? I would say both are challenging, right? Because of the scale. But I think a new challenge, and one that is really kind of unique, and where MLOps kind of needs to play a big role, is on the offline training pipeline, right? Because we know how to build web system that scales to billion of users, right? The multiple companies who have done that, it's more of a traditional software engineering problem. So inference is kind of a bit simpler in that way, but the offline training pipeline, they're more difficult because essentially they need to be stable while handling something that is extremely flexible and unexpected, which is the model, right? Because neural nets are, they have a lot of levels of freedom, and offering high reliability for input that has a lot of degrees of freedom is actually extremely difficult. And it's actually impossible to get to the traditional, 4959 reliability we're used to in traditional software systems. I'd love to hear other folks' thoughts on that.
Yeah, I'm going to put a pin in one thing that you touched on, which is we've had online learning algorithms from Valpo Wabbit and that kind of stuff for a long time. And I feel like that's almost a separate category. And now we're also seeing reinforcement learning taking a very large place. Facebook's Dino is wow. But so let's put a pin on that for a second, because Hans, you were talking about before 20 years of maintenance here. How does that tie into MLOps? How have you been doing it in the past? Oh, no, still can't hear you. Darn. No, we need to get this as a part of it, because Hans works with wind turbines where the wind turbines are deployed and maintained for 20 years.
Hear me now?
Yes, now you sound good. So tell us about the long-term MLOps.
So we we have a bit of a different challenge, I guess. We have had we've been collecting data from the field of the wind turbine for 20 years, longer than Facebook has even existed, I guess. Right? So that's that's a different sort of challenge. We have very let's call them legacy systems deployed in the field, owned by other people, our customers, and so that we have to move slower in that sense. We also have a timeline, basically, for any turbine delivered to have 20 to 30 years of warranty and operation of this. So anything we build needs to have that sort of scale in mind, which means that the way we've done previously is that we've been collecting data for 20 years, and whenever we spot a problem, a human spots a problem, we build a customized detector, sort of a data science tool, some threshold to detect on one of the hundreds of signals, and then we solve that problem. That's always reactive, and it's a very linear process. The more manpower we throw at it, the more we improve our performance. But there's a limit to how much you can do with this way of scaling. So that's one of the things we are looking into, is to go to the proactive stage, where we are discovering things before they have become a big problem in the field. We want to discover them obviously in the design phase, but also basically discover them before we have deployed many turbines with a given problem or a given issue. And that's where MLOps and these things are coming in, because that's the way we believe we can scale the number of models in a way where we keep in control and having 10 times as many customers or 10 times as many models without having 10 times as many people trying to monitor them. As you know, the talent is difficult to come by in the area.
Right. Yeah. So I think we're starting to narrow down here a little bit on the types of things that are happening now. We have deep learning, we have cloud strategy and data sharing, and a couple of other factors that might be making more demands of DataOps and MLOps than before. So Nishant, can you expand a little bit on the data sharing and why that actually makes a difference, and what kind of demands it places on DataOps, why it's important to be structured?
The data sharing, it's a key, right? I mean, before you can go and do any intelligence, and understanding what you can actually get out of the data. And in traditional manufacturing, what you would see is there's not just one supplier, but in one factory, there are about equipment from 10, 12, or even more different suppliers supplying their own piece of equipment. And to expect the end customer to have an expertise on each one of them, to be able to understand the data on each one of them is unrealistic, to be fair. There are a lot of companies that I've seen that do offer that, we can do a predictive maintenance for everything. But actually, if you don't know the underlying process, then if you don't have the domain knowledge, then you can't actually add value to this. So that is where it's becoming more important that the supplier's own data, such as you were saying with the wind turbines, right? You want to have your own equipment data with you, so that you can apply your year's worth of domain knowledge with expertise and add some intelligence. So that's that strategy itself, in terms of sharing data outside of a factory in a secure way, is becoming more and more important. and that requires then for us to to have reliable cloud infrastructures.
How much does this align with the vendors' sort of contextualizing of the features? Vendors are talking about feature stores, for example, and it seems to align a little bit with what you're saying, that there needs to be sort of a structure, given that you have many vendors producing data and that kind of thing. How well does what the vendors offer now actually align with what you feel, the requirements that are coming from your organization from this data sharing and cloud reality?
It isn't there yet. I mean, I think it's still in the exploratory phase. An ideal scenario would be that it's basically these elements are available as apps for manufacturers to just tick and select, and it's up and running. It's been trained on one side, but it's actually deployable. That same predictive maintenance algorithm is deployable across other sites of the same customer because it's using similar parameters. But currently it's only companies such as ours, like Atlas Copco, because we have a big global footprint. We have that access and that relationship with our customers to take that first step and build that trust with them and be able to do some of these activities. Also, what we benefit from is within the same plant, we own 5 of the equipments of so we also have a larger portion share of different types of solutions going into the customer. So it gives us an opportunity to be able to offer that and do that pipeline for intelligence across those equipment and start to add value. But I think within manufacturing, it's still like very early stages. Over the next couple of years, I do see that changing dramatically. And once we start to prove and the trust starts to come from the customer, is when the importance of optimizing, the DataOps pipeline, the MLOps pipeline becomes more and more important.
All right. I think we want to get into the nitty-gritty of the tech stuff in just a moment, but I want to hear both from Hans and Hagai here a little bit on what you, in your daily work, how you see the relationship between the part of MLOps that is sort of data prep part and the part that is live part. So Hagai, I mentioned before Vapo Wabbit. I'm not sure if you're familiar with that in specific, but you guys probably have a lot of opportunity to do things like A/B testing and online systems, maybe, as opposed to purely offline models. So for you guys, is MLOps more about the deployed stuff, or is it more about the data prep stuff? What would you say is the proportion? And do you see that changing?
Yeah, I mean, I would say the answer is both and more. There's really, we can't give ourselves any discount, right? Both are critical. So, let me actually start with the online, right? Serving. Of course, A/B test is a necessity, right? Because there is no other way to ensure that the new version of the model is better than the previous one, and to quantify by how much. And the reality is, by the way, there's actually so many different metrics that we measure and look at. And usually, like for those who ran A/B tests, right, it's always, you need to like factor in, because there's always some trade-off, right? Some metrics are better, but then others are not as good. And then there's a business decision to make on what are we moving forward with. So, A/B test is a necessity. Serving with low latency is another necessity, right? Usually when you have unless you're doing offline batch inference, when you're doing online inference, right? A user is opening, her phone to see the Facebook feed, for an example. And there's actually a very limited budget by which we need to serve the recommended posts for the user to see, right? So our online serving system has to be, super scalable, super performant. It actually imposes a lot of metrics. We also measure in the A/B test around the inference latency. So, and I can go on about online. Then on offline, just to give an example or to illustrate why offline is so critical, one thing that is a bit unique about the field of recommendation is that the training data has a temporal property. The fresher your training data is, the higher contribution it will have to your model being accurate, right? So, and I think it's, intuitively it should make sense, not for all recommendation tasks, but especially for those on social media, right? Because the reality, our world is always changing. There are trending events, trending posts, trending people, right? So we have to always retrain our models on the latest data. And for our key models, we train them every few hours. So if our pipeline that gets the training data ready, or that updates the models, etc., if that is blocked, if that is not working, the prediction accuracy is actually impacted significantly and has a business impact. So the offline is definitely just as critical, and we actually treat it as production. So our offline pipeline is the same category as our online system. Not all of it, but a large part of it. There's another.
I'd like to hear from all three of us, like what kind of metrics we actually should be doing. I think, like, when it comes to vendors, you hear about what sort of systems should be in place, but not necessarily to what end in terms of a measurable metric. So you'll hear about a feature store, but why do you want a feature store? What are you trying to measure, and that kind of thing? So Hans, I'm very curious to hear also your perspective on if there's anything that changes between having models at the edge and not, because you guys have a very physical aspect to your deployments. Is there something between models, close to the wind turbines and that kind of stuff?
Yeah. So we have obviously things going on inside of the turbines and going on sort of the plant, which is the group of turbines at a specific customer, and then stuff centrally. And basically, we see the difference here in sort of a speed of deployment. Whatever we do centrally, we control completely, and we can update whenever we have a new thing. Whereas things that are deployed to the turbines basically have lead times of months, and that is mainly due to customers need to accept new updates, new changes. This is very critical hardware. If we somehow make a mistake such that the grid can be compromised, well, we can all imagine what happens. We saw it in Texas recently. So there are some very strict requirements that we do not disturb the actual production. But that means that we can do a lot of stuff centrally and just send recommendations to the turbines that they can optionally follow. But if we actually go out and deploy models at the edge, we have to be a lot more careful on those things. So that's the challenge we see there.
Is that something that has been changing in the past couple of years, or have you guys? And how come? Did you serve? Now, well, I'm wondering, how did you do 15 years ago, and what's different from then and now?
I've only been in the company for 5 years, but the story goes basically when wind turbines were a small fraction of the grid, it didn't matter too much how well they performed, because the big base loads of coal, nuclear power plants, and so on, they could handle whatever. But in Denmark now, for instance, on an average day, 50% of the power is coming from wind turbines. That means that, and if a large fraction of those are Vestas turbines, and we somehow make a mistake, we can bring down the grid, right? So
right.
That's the sort of thing that has changed. We are being put to a much stricter requirements now, understandably, to make sure that these sorts of things don't happen. And then also in Denmark and Northern Europe, we have very strong grid, but there are other countries where the grid is much weaker due to either sort of aging infrastructure or due to basically lack of proper production and so on. So, and that's where the wind turbines are supposed to be now a benefit to the grid instead of being a sort of a destabilizing factor.
Right. That's a great conceptual leap to make here, where we might have been doing machine learning in one form or another, but it has not necessarily been mission critical to a company in the way that it can be nowadays. Not only because people have their eye on AI and ML, but also because the kinds of problems that we can solve with AI and ML are more conceptually complex and perhaps become mission critical because of that. Nishant, I'd like to hear your thoughts on two things. One is, what facets of MLOps do people not tend to think about that they should be sorry, that they should be thinking about, and what might you want to be measuring? Like, how do you measure that you're doing it well?
So for us, I think it's critical that having the right infrastructure set up across, especially when we have different product lines. So my responsibilities across the division, which has 5 different products, which are these big physical machines that go end of robots. Now, we have the right infrastructure needs to be in place so that the data collection pipelines are set up. We are not basing, we want to do ML models, yet data collection in certain cases exist only on Excel spreadsheets. There are systems which have been running for 12 months, and if it stops, it's like reliability testing that needs to be run for 12 months. Yet the data on that is stored on one laptop, and there's so much data generation and data wastage that happens, right? I think that's the first stage, and so the right infrastructure setup is critical for us to be able to set up and get towards the MLOps direction, and start to firstly with the resources and the partners as well, start to start analyzing portions of that, see what is of importance and where we need to start automating parts of the process. And that's the way to optimize that entire line, so that we know what's happening. It's not completely a black box, but that infrastructure and pipeline is a key.
Was it data waste you said? I think
yes.
that was, okay.
Yeah.
Can you expand? What does that mean exactly?
So it's to generate data from engineering systems, which are basically running in factories and stuff. These take time and take cost money. We join car bodies together. Every day we join, one of our equipment will join about anywhere from 200 to 1,000 cars together. So there's a lot of data points that are getting collected. So, but there's a cost. You need the physical car body. You need the physical setups to be there.
To collect the data.
Exactly. And similar things applied when you're running these systems, even in-house, that it's not just, running simulations, it's actually physical material that's required. So there's a cost that comes into play for all of this. And then from the different combination of joints that we can do, there's a whole range of that. So when it actually costs to generate that data and we are not storing that data or utilizing that data correctly, then we are actually creating a waste today. So that's for me within manufacturing domains, which are still very early phases within this whole process. And a lot of SMEs will struggle with this, is they're not utilizing this. They'll spend time and resources with a person actually recording this data on a piece of sheet, and then 1 week later you won't even know what was in there.
I think there's a huge opportunity cost as well. That's something I've seen in telco, where they will be collecting data and they will be storing it, but the experiment, like you said, is super expensive to run. And while you're running it, you might as well be very cognizant of all the things that you could be collecting,
exactly,
so that you don't miss the opportunity to collect more things that you should be because it's very hard to say. A lot of people say, well, tell me exactly what I need to collect. It's not always apparent beforehand. Exactly. What would be useful and what
you don't know what you don't know. And
yes,
the whole point of this is exploration, right? As a first stage with any new technology, you need to explore, do it in a sustainable way, right? So don't hoard data just for the sake of it.
Right.
But start doing and start being proactive with that process, so that you can identify where the opportunity lies, and you can start adding new sensors, because actually that might give you a perspective with that data which didn't exist before. And those all things can happen if you can do this in an agile way.
Maybe that's the correct way of expressing it, because I think people have been producing data, but there is like a sustainable telemetry type of mindset that is relevant. Hagai, Can you put some sort of quantifiable express sort of what kind of things you might want to measure? Like what kind of things should an MLOps, a person responsible for MLOps, be thinking about? I think maybe it's more relevant in online, but I don't know. What do you think? Maybe offline? Is there some way to quantify the efficiency of data storage? I don't know. What kind of numbers should you be, having top of mind?
Yeah, there's a bunch of, I think, metrics that are, key in the aspect of MLOps. Just briefly, I know I mentioned reliability a few times, so I think it's clear probably for all of you that I think this is like a, top concern because these systems are complex and are difficult to keep reliable. But, on reliability side, so, of course, what's your workflow failure rate, right? What percentage of your workflows are failing every day, every week? That is, in my mind, like a key metric and one that MLOps should optimize for. The second thing is also, so on the online setting, right? Depending on the business itself, one key metric can be what's your model refresh latency? Like how long does it take you to refresh your model, right, on average, or the P50 or P90 or whatnot? That's many times tied to actually key business metrics and even revenue. So those are just example of reliability. But another interesting metric I want to offer is that, in my mind, MLOps enables also developer productivity. And I'm talking about the machine learning scientists or developers. Because a good overall machine learning systems make it easier to explore new ideas, make it easier to test these ideas in A/B tests and deploy them to production. And that's actually pretty tricky to measure, right? Because of the exploratory nature of doing machine learning. I might spend a month on a model and then end up with nothing, but I actually made a lot of progress because I learned a lot of new things, eliminated some ideas, etc. So it's not trivial to measure success, but I want to share two, potential metrics. One is what's your, failure time on bad training workflows or training jobs, for example. Because again, because of the high complexity, some training jobs that people run, for example, in Facebook, can take a week or 2 weeks to complete training, right? If those models fail after, say, a week from when they started because of a problem that could have been identified earlier, right? A good system would actually fail you earlier, just like a good compiler would fail within, a few seconds, rather than fail when you're actually running your program in production. So that's the analogy I like to use for that. So actually, we're building systems that are able to dynamically inspect your job and fail it within 10 minutes rather than fail it after 7 days. And we actually have a metric and we goal on that. So that's one example of how you design a metric to measure how productive your ML system makes your machine learning developers.
Yeah, that's interesting. Now, I was just trying to think about how many companies that have jobs that take a week to train. We have a reinforcement learning model that takes a week to train, but it's not because the model is complicated. It's just there's a lot of game playing to do, so it takes a long time. But it's not clear if it will perform better or worse. It won't even fail. It just might not perform well. And so if everything takes a week to do, it's very important to be structured so that you don't end up doing the same experiment over and wasting time that way. Hans, I'm thinking from your perspective, we were talking earlier about the kind of skills that are required. And we've mentioned now today that not all the tools are turnkey solutions. So can you give some practical advice to people that are watching now in terms of what you think the proportion of in-house developed to ready-made tools, how should people be approaching that problem right now?
Yes, we are not all Facebook. We don't all have 1,500 devs sitting and using our tools. And we are not all in companies where the data science and machine learning strategy is coming from the top. So, for instance, we are very modular company, so that is a good because we can make our own choices and so on. But also means that we are more in control and in responsibility of our own tooling. So for us, it has previously been the case that we home built most things, but that means that data scientists end up doing infrastructure, which is not our key competence. So we've recently begun looking much more at turnkey solutions for a lot of the machine learning data science workflows we're doing. Basically, we want to make sure that we keep the control, but that we take out the plumbing parts of the work and give it to platforms. And there obviously the issue is that the platforms are themselves new, and these are challenging problems. And we are bringing our specific corner cases to a standardized solution. So that's been the challenge for us, is to take a sort of a standardized solution and customizing it to a place. So for instance, instead of having one big model to train, we have 1,000 models that are mostly identical, but basically we have 1,000 customers. So we have 1,000 models that need to be trained, and they can't be trained with each other's data. And we also have to basically, the example I'm thinking of here is power forecasting. I'll talk about it tomorrow in that session.
Have you been able to use sort of one turnkey solution for these kinds of pipes when it comes to at least the automation part, or is it for every step you need one specific tool?
Well, so we have attempted to use one of the sponsors of the conference, DataIQ, for at least the data science part here. So we have some pre-processing that is done basically by our data engineering department, so that we don't have to do this, and we try to have a very clear interface. But then we do the rest basically in this DataIQ platform, and this is where we had to do a bunch of customizations because we're abusing the system, let's say, with the sort of the scale of the data and with the many partitioned models that we're using and so on. So there are some challenges there in getting it. And then sort of the monitoring is also where we feel that we need to add some extra things on top. And also in the control, we have people who are not data scientists that are configuring these things. So basically, to operationalize these things, we need to have dashboards where you can do these three things and nothing else, and you're not allowed to be able to break anything by touching these things. You can only, if you mess up, you can only mess up for one customer at a time. That's the goal of those dashboards. And these are things that we have customized, built on top. We would have loved to pull that down from a shelf, but I don't think that exists, at least not in any maturity that we could get.
I think you're touching on something that's a little bit non-popular opinion here, which is that we should let software engineers do something that statisticians say might require a lot of finesse and that kind of thing. But the fact is that for data engineering, there's a lot of best practice to get from software engineering, and a lot of software engineers are pretty good at the job. I think from my perspective, that's the whole thing about machine learning, is that machine learning is science in its true form, where you do the experiments first and let that dictate what the model should be. So Nishant, I'm wondering, we were saying that it's hard to find the right talent. Does that apply to MLOps as well, or what kind of skill sets are required if people want to staff up for this kind of stuff?
So I think the skill sets are very important. Experience, the data analytics experience, experience with edge computing, cloud computing, experience with both machine learning and deep learning models development. All of these are a sort of key at the moment, and I think it's more also the personality, because from the type of people generally that I like to bring on board, including partners, are not necessarily people who have are superstars necessarily, but have the right intent. And even if they have the right intent, they can actually pick up, because especially in the software world, there's more than enough information out there for
it is learnable. This isn't some kind of to know some
I'm still learning it myself. right? So so it's something that I keep exploring and trying to understand myself, so I can better communicate what we need. So the skill sets, is absolutely important, and unfortunately is very difficult to come by, especially if you are in a domain which is not considered as a cool place to work. But you work in that domain, and I've been here for 8 to 10 years now, and I know that manufacturing is one of the best places to work because you can actually do so much stuff. Yeah.
It's all in the eye of the beholder.
Yeah.
We have 1 minute left, and Hagai, I would like to ask you, given that Facebook has the opportunity to lie at the forefront of a lot of AI stuff, what is next in MLOps and DataOps? What is like the upcoming trend, would you say?
I would say, actually, I want to just refer to the previous question real quick, and I would say the best people I worked with that took care of the MLOps of the ML system were software engineers that knew nothing about machine learning or deep learning. That's because they come with the right principles of software engineering, and these principles are just badly needed on the field of machine learning, which brings me to like, yeah, to answer your question, I think, again, maybe corresponding to your first question about MLOps, why is it like taking off? Why is it becoming so, like a popular buzzword today? I think part of it is just because there's a huge gap on the tooling side. Like for those of us who have been software engineers at some point in our career, when you look at the tool set that machine learning engineers have, it's just underwhelming, right? Like we're missing the IDEs, right? We're missing the equivalent of containers. We're missing the equivalent of a binary, right? When you have to deploy a model, there are so many different ways to do it.
Right.
When you want to run a program, you just compile it to a binary, and that's it, right?
Right.
So that's just a few examples. We're missing all these things. So, and when you look at machine learning, it's pretty early, especially deep learning, when you compare it to software. Software is an art of what, like 50 years, or give or take. Deep learning is like 5-6 years. So we need a lot of tooling. We need the cloud providers to build us better tools. We need big companies to give us better frameworks, better capabilities, and we need software engineers to build all of these.
Right.
Will it take 40 years?
Well, yeah, hopefully it doesn't take another 40 years, right?
Hopefully no.
Excellent.
Yeah.
Thank you guys for all your insights. We can stick around for a little bit and answer Q&A, but that's the end of the broadcast, and thanks for joining.
Thank you.
Thank you.
Thank you. That was fun.